Welcome to part 2 of Orbital Disassembly, where we are going to dig into the Q&A session at the back half of the Orbital Assembly Corporation's January 2021 video. Part 1, if you missed it, covered their live Zoom call sales pitch in detail. Watching that episode first will prepare you for this segment. The Q&A session appears to answer questions asked by the company's Facebook audience. As Shauna reads off the questions and various panel members answer them, they all seem confident and reasonable enough, until you start thinking about them critically and start researching their answers. In fact, in the end, almost none of the answers make sense, yet if you can read between the lines, they tell you more about the project's viability and readiness than the previous 35-minute presentation did. Noticeably absent from the Q&A was the New York City lawyer James Wolfe, which is weird, because according to him, this whole company was envisioned by him. Here we go with question number 1.
Will Gravity Ring be incorporated into the future Voyager station, or will it remain a separate project?
Gravity Ring is a technology demonstration project, so it could have a life of several years in space if we have additional funding from NASA or other space agencies or even private entities who want to do long-term partial gravity experiments. And also, the Gravity Ring is only a 40% scale version of the Gravity Ring of the Voyager station outer ring truss, and so we can't use it in that context.
And the answer was no. The two structures are different projects, and the smaller ring is 40% smaller than the Voyager station. Although that's not a great answer, because with a little tweaking they could probably use that ring for the inner structure where they've planned the landing bay. Waste not, want not, right? Especially in space. But the rest of the answer Jeff gives is more informative than he probably meant it to be. The takeaway from this is twofold. First, and probably most importantly, this project is going to be heavily dependent upon obtaining further funding from NASA or other agencies or other investors. However, as we discovered in part 1, NASA already has their OSAM program in place and has been commissioning projects that are due to fly shortly. So this money probably won't be coming from NASA. And the other international space agencies are all NASA partners who would assist in their projects. So unless OAC would like to drop some names of people or organizations to verify this information, let's treat this call out as the nonsense it appears to be. Second, Jeff says this project's lifespan might last a couple of years without additional funding. So at the end of the lifespan, or when the project fails, it would leave this giant hoop-shaped structure floating and spinning in space. And their plan is to have this in the same orbit as the ISS, either trailing it or leading it, in case they require assistance. Apparently, these guys think the ISS is on call for space emergencies like some sort of orbital AAA, and they have shuttlecraft or something similar standing by to fly over and get them out of a jam. The problem there isn't the laughable claim that ISS would be ready, willing, and able to assist. It's that this contraption could possibly endanger the ISS when it is abandoned, if it's not deorbited, and that action would endanger other satellites in low orbit on the way down. Before the second question is announced, Shauna supposedly reads a post from a fellow named John Olds at a company called SpaceWorks Enterprises, Inc., offering to supply this project with modular connection nodes.
John Olds says they're developing modular connector nodes for in-space assembly of large structures and platforms. Good luck, we should talk. John, we encourage you to reach out to us at info@orbitalassembly.com. We would be happy to talk to you further.
Shauna suggests John contact them to discuss this offer further. However, this shout-out was almost certainly a plant meant to convey credibility, kind of like the advisors at the end of part 1. Here's why that is likely the case, but it's a bit of a tangent, so stick with us. John Olds is the CEO of SpaceWorks Enterprises, Inc., also known as SEI. The address given for SEI in Atlanta, Georgia is Suite 1400, 1050 Crown Point Parkway. That's this building, the Peachtree offices, which is operated by DaVinci Virtual, a company based out of Salt Lake City, that offers virtual addresses and boardroom rentals to businesses at this address for rates starting at $75 per month. According to Wiki, SEI was founded in 2000, and it lists 3 subsidiary websites, 2 of which are dead links. Both of these other LLCs appear to still be around, however, just operating under the exact same business address as SpaceWorks. Although, according to this same page, they haven't done much since 2014, when they participated in a NASA Innovative Advanced Concepts project studying human stasis using torpor for Mars missions. But if they ever created such tech, that breakthrough has escaped the world science publications. In reading the conclusions of their 2018 final report, here's what they came up with after 4 years of looking into this. First, SEI wanted to put space travelers going to Mars under, using their proposed process, for 70 to 80% of the trip. Once under, these persons would be fed a liquid enteral solution through tubes in their chest. And to keep these persons in torpor, defined as a state of physical or mental inactivity, they would chill, then drug those people with dexmedetomidine, which the researchers identified as an excellent candidate for providing light sedation. Dexmedetomidine, also known as Dex, is sold under the trade name Precedex. This sedative has an elimination half-life of 2 hours and is metabolized in the kidneys before being excreted in the urine as metabolites. As with every sedative, prolonged exposure develops a tolerance to the drug in a patient. The effect on the kidneys of having to constantly burn off this drug for months at a time is one concern. The fact that kidneys in chilled conditions don't function the same would be another. And the realization that the kidneys would be at the same time accumulating shed calcium from bone depletion due to weightlessness pretty much wraps up a trifecta of potential renal issues. Further, this is a drug whose side effects are known to include hypertension, hypotension, nausea, bradycardia, atrial fibrillation, hypoxia, and low blood plasma. Overdoses of this drug can cause first and second degree atrioventricular blockages, and the sedative used in ICU procedures has a listed maximum exposure of 24 hours. But this sedative was their perfect candidate for drugging astronauts, and that's all it would have been, a drug-induced stupor. So here's their solution for getting people to Mars. Pop them in the freezer, drug them with a sedative that will probably burn out their kidneys and play a tap dance on their heart, deprive the patient of oxygen, and drop the body's ability to fight off infections, and keep them that way for 6 to 9 months. Basically, it wouldn't be much of a stretch to say that they were paid a lot of money to watch the movie Aliens and then tried to reverse engineer their hibernation process. And they got paid at least $100,000 for that. Now, this is all a little off topic, but the key takeaway here is that just because some person or group gets NASA money to look into things, doesn't mean they have a clue about the subject matter. That being said, SpaceWorks seems to be more of a think tank than a manufacturer, although they advertise some products on their website. There's the X60 airdrop test platform, which is in development with an SEI subsidiary called Generation Orbit. The X60 has not reported having conducted any test flights, despite receiving their initial funding in December of 2013. Other products on the SEI page are GPS cubes for use by farmers, and similar cubes for tracking oceanic currents, pressure, and salinity, both of which carry the Blink branding. And of course, that link is dead. They also have some small proprietary electrical connections, and 2 dome-shaped re-entry devices, none of which seem to have any sort of track record, all of which appear only as CGI images on their website. But even then, there's no mention, as far as we can see, of the modular connections as suggested in the comment that Shauna read aloud. And if they do have them, OAC would already be aware, because John Olds and his company SpaceWorks are no strangers to members on this panel. Remember in part 1 we mentioned the SPS Alpha project that was flashed up by James Wolfe when he was presenting his inflated claims about contracts OAC has, in principle, already with Mankin Space Inc. That was this claim.
We have our first customer agreements in principle executed with companies like Mankin Space Technology Inc., the space-based solar power satellite company founded by Dr. John Mankins.
Guess which other company was involved in that 2011 proposal to NASA? SpaceWorks. In fact, it was John Olds' team that drew up the renderings for Mankins. So Mankins and Olds know each other. In fact, they're often on the same speaking tours. For this panel to pretend they don't know him, or for Olds to make a comment on Facebook pretending to make that introduction out of the blue, well, that just throws more shade on an already dim presentation. While we are revisiting the topic of the SPS Alpha project, would you like to know what the report review on the proposal came in at? For a small-scale pilot prototype, they were looking around $5 billion. And a full-scale operational unit? At the low end, that was a $20 billion project in 2012, or about $23 billion today. Now, does this guy look like he's got over $20 billion lined up to put this contraption into orbit? No, he does not. So let's see James Wolfe present the contract they apparently have signed in principle with Mankins and what project it's for, because it sure as shit is not for the 10-year-old CGI images of an orbiting solar power station as shown in this presentation. Question number 2.
Will we be using a type of monopropellant to spin the station up or down, or something like a reaction wheel?
It hasn't been decided yet, but we will probably be using exactly what the propellant mix will be.
Will they be using monopropellant to spin the ring up and down, or will they be using something like a reaction wheel? Answer is, they haven't decided yet what the propellant mix will be, but it will probably be a monopropellant. This should set off alarm bells for the viewers. If they don't know what fuel they'll need, they can't know which type of thruster they're using, which means they don't have a thruster supplier lined up, which infers they don't have any idea where they're getting this equipment from or what it costs, because they simply don't even know what type of equipment to buy, how many will be required, and what type of control systems they'll need to install. Further, that means they can't possibly know what type of payload weight they need to lift to orbit, which means, again, their launch logistics cannot be worked out. Also in this segment, and according to John Blinkow, the assembly of Gravity Ring is going to be completely autonomous using P-Star.
For Gravity Ring, that is going to be a completely automated construction.
Claiming the orbital manufacturing plant can create a perfectly circular truss that will line up perfectly with the back end of the assembly unit when it comes full circle, that's one thing. Claiming that it will run control system circuits, power cabling, propellant plumbing, and then connect everything together on the outer ring, that is a completely different level of disillusionment. And all that can be discerned from them simply not knowing what kind of fuel they're going to use. The third question proposed to the panel is kind of an important one, especially for people who have joined up with their crew memberships.
So Nick Vanderpeers asks, have we already started a civil multidisciplinary crew for exploring space? And then Stephen Nancaro asks, how are people being trained to work in space? Are they being trained now, or is that path being planned out now? So who wants to take that on?
I'll take that one. Crew training for deep space exploration is not our thing.
So you got that, right? According to John Blinkow, the guy who's been taking your money, crew training for deep space exploration is not really their thing.
But we're probably going to be not training them ourselves. We're going to be looking to NASA and other space agencies for a crew who have space time.
Let's break these statements down. Neither Orbital Assembly nor the Gateway Foundation will be providing space training for people to work on the station. And they are under the impression that former astronauts will want to sign up for construction jobs and wait staff. So you have to wonder, how many waiters did NASA train last year? How many housekeepers? How many bartenders? And is this company seriously looking at paying the average astronaut wage of $100,000 a year to change sheets and wash dishes? All of the people who have bought their annual and lifetime memberships really need to take a close look into the promises the company has made to date. The lifetime memberships Blinkow was peddling heavy last year included crew seniority numbers, but now he says you'll have to be trained by NASA to be accepted into these jobs. Here's the clip from him last year pushing those crew memberships.
Every structure on Earth has a foundation. The Gateway Spaceport will have one too. We cannot build this structure without you. You are our foundation. If you'd like to help this important project, please go to the Gateway Foundation website and join our crew membership. It's important.
How many of these people who ponied up $500 for these memberships do you think have already spent time in space and received full training from NASA? But we found some good news for anybody who has paid crew membership fees in his video from 2018. He declares crew memberships are 100% refundable.
Someone asked how many crew memberships there are. Join our crew membership and then you will know. If you don't like your seniority number, that's okay. All crew memberships are 100% refundable.
So if you are reconsidering your purchase, you can call their 1-800 number, 1-800-987-0238, Monday to Friday, 8 to 5, to get your money back. And if you know anybody that does this, please videotape that interaction and send it in to us ASAP. That would be a very interesting conversation to be a bug on the wall for. John then says they will have 6 to 8 people in space to build the Voyager station using robotics and equipment.
But when it comes time for us to start building Voyager station, then we will launch OCC Alpha, which is the command center for the construction. And that's going to have about 6 or 8 people on board, and they will be building the station.
The claims here are ridiculous, but let's just focus on the manpower. Currently, the cost of getting a single astronaut to the ISS at an elevation of 350 kilometers using Soyuz rockets is $81 million per seat. On Crew Dragon, the cost runs about $55 million. So launching a crew of 8 people into a 350 kilometer orbit runs about $440 million. But to date, no NASA astronaut has been launched into a significantly higher polar orbit where they say this project will reside, as we are about to discuss shortly, so those costs would be significantly higher. And then John makes a throwaway statement that's kind of important. He says, at that point they're going to launch OCC Alpha Command Center.
Then we will launch OCC Alpha, which is the command center for the construction.
That's supposedly remote operating and living quarters for the construction workers. Where are all those CGI images and blueprints and cost estimates? They seem to be completely missing from this presentation. And we seem to recall that that module was part of the Gateway project and was in itself an enormous undertaking that would likely cost hundreds of billions of dollars. Here's question number 4.
He's asking how people will walk from the docking ring in the center to the outer rings while gravity would be increasing the entire time.
Here's the answer given by Tim Alatorre.
And you'll have an elevator that you'll get into. And so that elevator, as you're extending out towards the outer ring of the station, you would be feeling those forces start to pull on you, but we would have harnesses or grab bars, and as you're going down, you would start to feel yourself being pulled to the floor. And then as you get to the outer ring, then you'll be able to walk normally.
Now let's compare the answer given by Alatorre with the CGI animation provided in their opening credits. Here's a guy riding the elevator from the center of Voyager to an outer ring. Do you see any gravity bars, or harnesses, or any other safety gear? Or does this look like he's just going to his underground parking garage in his big city condo? Also, while we're here, let's take a closer look at this diagram, and you'll find that when the elevator isn't parked where it's expected to, there's a giant hole in the floor with apparently no way to block it off. Notice that at the bottom of that shaft is what we are to assume is a thruster assembly with 3 visible nozzles of what we would expect to be a 4-nozzle system. There is no representation of a 5th nozzle coming directly out the end that could move the station laterally. And there are only 2 such installations visible on their diagrams, at 12 and 6 o'clock as it were. That creates another bunch of questions. One of the first is, would they really mount this system at the bottom of one of the 4 elevator shafts that gets you to the center of this structure, when an explosion of propellants in that location would rip straight up the channel and directly into the docking bay? Second question is, do they seriously intend to use pairs of these tiny thrusters to spin this entire system up and down? Time to compare vaporware to the real thing, so we're going to put the station design spec sheet up against the ISS directly. The ISS, with a mass of 420 tons, has a pressurized volume of 916 cubic meters. The specs on Voyager station says the station will weigh 2,418 tons with a pressurized volume of 51,104 cubic meters. Right off the bat, something doesn't add up here at all. Voyager weighs 6 times as much, yet has 58 times more volume? Not bloody likely, considering the ISS doesn't have massive walking corridors, or elevators, or 44 lifeboats hanging off the frame. Regardless, we're going to work with what they gave us. The service module of the ISS, the beating heart of the station, has 2 main engines and 32 attitude control engines for station keeping and relocation. The FGB, the functional cargo block, has another 2 docking engines, 24 docking and stabilization engines, and 16 accurate stabilization engines. On occasion, the ISS is also boosted by the orbital correction engine and 28 multi-directional attitude control engines on the Progress cargo module. Add those numbers up, and the ISS has over 100 engines to pick from. And how many does the Voyager station have mounted on their CGI space hotel? A grand total of 8. Pretty sure you could burn those babies until they melt down and you still wouldn't get the station spun up properly. Maybe there's someone in the comments section who would like to run the math on a thruster 1 meter tall with a propellant tank no bigger than the available space at the bottom of the elevator shaft and the chances it has of possibly getting Voyager rotating. It's unlikely that anyone thinking these little nozzles are going to get something this big moving that fast is basing their numbers in reality. There's been something else bugging us about this image and we couldn't quite put our finger on it, but we did finally figure it out. See this fellow? He's a representation of an average human male, height around 1.8 meters, call it 5'9". The habitat he's walking into is supposed to be 8 meters tall between the floor and the ceiling, between the walls of the outer hull. But if you take our 1.8 meter tall guy and you stand him on top of himself over and over again, and leave a little bit of room between these figures to consider he's walking and slouching looking at his smartphone, you can easily fit 8 of him on top of each other, meaning that width doesn't represent 8 meters, instead it's actually over 14 meters tall. Now if the figure of the man was to scale, the 1.8 meter tall guy should have been at least this tall in the image. In a 4-deck module, the ceiling would be at best 2 meters high, or a little over 6 feet. And all of the other CGI images representing Voyager Station are off by similar factors. He gets it wrong in the restaurant, he gets it wrong in the suites. How does a professional architect mess up dimensions this badly, unless he's doing it on purpose? Question number 6 deals with orbit parameters, and we did touch on this a little earlier.
What are the orbit parameters? Will we be in a common orbit offset from the ISS, or how close to the ISS?
Gravity ring, we plan to put in a co-orbital with ISS that would either be ahead of it or trailing it. Ideally, Voyager Station would be in a polar sun-synchronous orbit where it'd be getting sunlight 24/7, would have a very stable power and thermal environment.
Gravity ring would be co-orbital with the ISS, which would present huge problems for the ISS if, for some reason, the rotating structure became uncontrollable. Now, they claim that the larger Voyager station would be in a polar, sun-synchronized orbit. That would put it directly in the sun 24/7 and would have a very stable thermal profile, according to them. As part of the answer, Tim Alatorre pipes in with this.
We have designed it to be in that sun-synchronous orbit. And if you look at the renderings and the designs, one side of the station has all of the shielding and the solar panels. The other side has all of the viewports and the openings. And so we're designing it, and the radiators.
One side has all the solar panels and the shielding, the other side has all the viewports and the radiators. Now, there is no mention of what they're using for shielding, but as we've discovered before in other episodes, shielding is going to be a problem against radiation in space. There's no two ways around that, and the polar orbit may make things even more difficult. Now, I also mentioned radiators, and they should be out this side of the station, but where are they in these illustrations? Where are the representations of the radiator panels, such as those that are used on the ISS? Also, polar, sun-synchronous orbits are typically within a thin window of orbits, and they keep a velocity of around 7.5 kilometers per second as they traverse the planet from north to south and back. Most satellites in orbit are rotating around the Earth perpendicular to this motion, moving from west to east. By launching into the eastern sky, rockets take advantage of the Earth's rotation to get into orbit. Now, you combine these facts, and you would have most launches moving across the planet, also traveling at 7.5 kilometers per second, who would then have to change their course somehow by 90 degrees to intercept this station, which would be zipping up and down. And then they would have to catch them. At this time, we'd like to introduce you to a special guest and a segment he prepared especially for this episode. This is YouTube's pressure-fed astronaut, and this is his area of expertise, so let's hear what he has to say about the OAC polar sun-synchronous orbital claims.
So a sun-synchronous orbit is a special kind of orbit that, as the name suggests, has the spacecraft always bathed in sunlight. It's a weird byproduct of the fact that Earth is an oblate spheroid. It's kind of complicated, so we're not going to talk about it much. But for an 800-kilometer orbit that's sun-synchronous, your orbital inclination has to be about 98.5 degrees, which places it in a polar orbit. To get to a polar orbit, your rocket has to either go north or south. And if you want to launch from the United States, there are two places you could go. Vandenberg Air Force Base in California, or if you hate yourself, the Pacific Spaceport Complex in Alaska. So the reason you'd launch from Vandenberg or Alaska is because what's directly south of them is just the Pacific Ocean. There's nothing for the rocket to fall on. So what we're looking at here is a limitation on the launch azimuth. So a rocket's azimuth is the direction it's pointing when it takes off, and it's aiming for a certain orbit. Now, launch sites and launch ranges have corridors rockets can go down because of things in the way, right? There's an island in this one, there's land here. So there's corridors that a rocket can go down when it launches, leading to certain orbital inclinations that are attainable. So for example, here's Brownsville, which, hey, that's where SpaceX wants to launch from. Now I've drawn in the orbit you want to hit, going this way or going this way. So let's take a look at Kennedy. Kennedy Space Center has a wider variety of inclinations you could hit from the launch site, getting from 39-degree orbits to 57-degree orbits, neither of which are 98.5. But you could do a polar launch from Kennedy. So SOWCOM 1B is in a sun-synchronous orbit at 97.2 degrees, launched from Kennedy following a trajectory like this. So the Falcon 9 went up and then turned, the dog leg, right? And Starship could theoretically do this too, with one catch. You will be flying over Cuba. Now the reason we didn't do polar launches from Kennedy up until last year was because a Thor missile tried this, blew up, and parts of it killed a cow in Cuba, and they got very mad. So Starship, assuming it has similar performance to Falcon 9, could follow the same trajectory and carry up 53-ish metric tons to the 800-kilometer orbit. This depends on two big factors. So the first would be just Starship operations. And secondly, Cuba might just say no. So could Starship launch parts of this space hotel from Brownsville, Texas? Absolutely not. From Kennedy Space Center? Maybe.
PressureFed's YouTube link is in the video description below, so are the citations that he asked us to include, so please check out his channel and give him your full support. End of the day, Musk's Texas location, where he reportedly wants to build Spaceport City, USA, won't be launching anything into a polar sun-synchronous orbit. It's just not possible. One of the items PFA brings up is that for the polar sun-synchronous orbit, Starship's payload capacity would be cut by more than half to about 40 tons. So however many launches they were planning on having, it would be 2.5 times that many. And they would have to launch all of them from Kennedy Space Center. Next question.
Hiring. When and how will that happen?
We're going to start hiring pretty soon. That's one of the reasons that we're getting together this money.
When will you be hiring? And according to John, they're going to be hiring pretty soon. Jim Alatorre brings up the fact that John is the president of the Gateway Foundation for the first and only time that this is mentioned throughout the entire broadcast.
John's also president of the Gateway Foundation, and so the crew membership over there, we already have a lot of contact information from people who've supported us, from even before Orbital Assembly Corporation was a company.
In fact, most of the people on this screen claim to hold positions at the Gateway Foundation. As we went over in our previous episode about the Gateway Foundation and Orbital Assembly, the Gateway Foundation is a rented UPS mailbox in Rancho Cucamonga, California. And according to the BBB page, it is a sole proprietorship owned by John Blinkow. Sole proprietorships don't have presidents, COOs, CFOs, and the like. They are legally indistinguishable from the individual owner whose name is on the document, meaning that literally any money people send to the Gateway Foundation for annual and lifetime memberships goes directly into John's personal bank account. Meaning, when he eventually gets sued by the people he duped out of money for crew seniority numbers, you'll have to sue him personally. That also means that the Gateway Foundation is not a recognized charitable foundation as defined by US taxation law, which we also went through in our previous episode. Question number 8 is kind of important. Is SpaceX a partner?
So someone wants to know if SpaceX is one of our partners. They saw a picture of the SpaceX Starship, so they were just wondering what is the status of that?
We cannot call SpaceX our partner, but in the future we look forward to working with them because they are one of the large launch providers out there that we can utilize. And of course, Starship is, it's the big kid in the block. So when you want to launch some heavy equipment into space, that's your best bet. But we don't have a contract with them yet, but let's just say hang tight.
So right there, John Blinkow states that SpaceX is not a partner and they have no contracts in place. But hang tight. Hang tight to what exactly? We've already discovered that SpaceX won't be launching Starships into a polar sun-synchronous orbit from Spaceport USA. The pressure-fed astronaut identified Vandenberg Air Force Base and Kennedy Space Center as the only possible launch plans in the lower 48 for that target orbit, but according to SpaceX, Vandenberg is off the table. So that really leaves one option, Pad 39A at Kennedy Space Center to launch from, and multiple launches per day from that facility are not going to happen. Yet, every one of the animations shown in this OAC presentation exclusively uses Starship as their delivery vehicle, and this is a gross misrepresentation on all levels, even if Starship was a viable delivery system. Question number 9 is kind of laughable.
How can someone buy shares if they are interested?
Shauna drops another planted question. How can somebody buy shares? Well, the only person who would have to ask that question wasn't paying attention during this entire Amway-style hard sell and can't read the bar at the bottom of the screen. It was bad enough they were shouting it out every 2 minutes, but pretending someone actually asked that question, that's pretty shady. Next question.
What is the total assembly cost of the orbital gateway? I think that's referring to Voyager station.
Question number 10. What is the total assembly cost of orbital gateway is the question, but Shauna deflects this to Voyager station, which would seem to indicate that gateway was not supposed to be mentioned here at all. Nobody has a clue how to answer this.
The total cost for Voyager station, that's a lot of that's depending on launch costs, and that's been coming down, so it's not easy to nail down that exact number. However, in our prospectus, we outlined a very detailed breakdown of what it would be, and I'm going to let you go ahead and talk about that, Jeff, because you're involved with that, about that breakdown.
And John actually throws Jeff under the bus here after stammering on about launch costs and how they're coming down. But we all know that's not really the case, not in any significant amount. After Jeff rambles on for a minute, he states this.
I would say it's still preliminary. You know, there's a lot of things that we have not gotten to the point where the engineering is finalized to be able to put a price tag on. But we are definitely looking in the tens of billions of dollars for the full construction of the station.
Could be in the tens of billions of dollars. Both of these men obviously forgot that they've previously given that number out in other news releases. It was $60 billion. But here's why they might have been shying away from that answer. Here's what $60 billion looks like when it's written out as a full number. And here's how much money they raised with this little stunt. Now this is how many more times they have to pull this stunt to finance the $60 billion figure. They would need to do this another 59,999 times. Except if you work out the math at $18,000 per kilo in current launch costs, that's only enough money to launch 333 tons of raw, unassembled materials into space. No people even. And that might be enough weight allowance for the gravity ring, but it's certainly not building any orbiting space hotels. Question number 11.
What kind of mod will we be using, rigid or flexible members in the ring instead of the habitat modules as the rigid members? And commenting on the flexibility versus rigid design. Who wants to take that one?
Indeed, we are going with rigid modules, and no, they wouldn't fit in a standard Starship or New Armstrong fairing, but there are ways to get them up there without even having those fairings.
What kind of modules are they going to use, inflatable or rigid? This is a question that Tom tries to answer, and he identifies rigid modules as their choice. Then he suggests that there is a way to launch rigid modules into space without the benefit of fairings. There's no mention of Bigelow, who makes similarly shaped modules as inflatables. These modular habitats measure 8 meters across with a length of 12 meters. That is far larger than any payload fairing currently in operation. At this point, Spilker claims that the modules will be completely built on Earth and that there are ways of getting them into orbit without providing details on who's building them, or where, or who would be launching them, from where, or in what. So in this incredibly vague answer, he's sounding a lot like somebody else here.
It's really, I swear it's not that hard.
Question number 12 goes to Tim Clements.
How do we check the quality of the structure welding in order to hold 1 atmospheric pressure?
There's a various number of applications that we can apply and try to use prefabricated sections and couplings and various other items to eliminate that work in space as much as possible. But there are friction stir welding methods and other methods that will be autonomously produced.
This is the only time that Tim Clements piped in, and when he did, he mentioned friction stir welding, so that demonstrates Tim's lack of understanding what that process is and how it might work in space. Friction stir welding is when friction is used to create heat across two surfaces that causes them to melt into each other. Considering the material they might be welding in space with this technique, where the temperature can approach absolute zero, the chances of them creating a process that creates enough heat to forge a solid bond is pretty slim. Also, FSW requires applying significant pressure on both sides of the seam while it's being fused to create the friction, which would require either hydraulics, which would freeze up, or mechanical gears and chains that would wear out. So this brings up a great point, and our viewers picked up on this to send a NASA document our way about welding techniques in space. In short, there currently are none. This NASA report, released in April of 2020, identifies several unproven technologies that are currently under development, including laser welding, electron beam devices, and an ultrasonic additive system that works on foils, each of which has their own drawbacks, all of which will require extreme amounts of energy to operate, and nobody so far has brought up a single powering solution for their star prototypes. One of the platforms in the NASA paper, being developed by Busick Co. Inc., which looks to be a similar concept, would require an umbilical line carrying power and telemetry commands from a host space vehicle, which is obviously something that OAC has not planned for. Not one of the processes being looked into in their 23-page report mentions friction stir welding. So no matter what these guys are promising to showcase later this year at their rented warehouse in California, it's not going to be suitable for working in space. Shauna wraps it all up with another hard-pressed sales pitch. Then VIPs got shunted into their private chat rooms, presumably for people who have lifetime or annual memberships. But the end credit video montage raises a bunch more questions if you're actually paying attention. Starting off with the supposed fabrication progress of the D-Star, showing 4 lightweight frames with crossed members rolling out in an assembly somewhere. All the chains and gears they demonstrate in the various shots would serve no function in space. The chains and rollers and required lubricants would freeze and seize up. Next up is a screenshot of Orbital Ring and Voyager Station, but if you notice on the Orbital Ring, the fabrication unit is not the same as in the rest of the presentation, and this Voyager Station only has 2 elevators, not 4. In the motion picture industry, this is a term called lack of continuity. Then we have freeze frames of the Bigelow type halves, the grabber bot that doesn't exist and has legs for some reason, and the other fat round bot that's not even up for development until 2024. Then there's the shot of the backside of the station where you can't see any radiator panels, complete with the suicidal guest that's out taking a walk on the inside of the ring. A full shot featuring starships, again, docked in the hub, and $20 billion worth of SNC Dream Chasers parked around the edges as life rafts. Neither of those companies have signed on with this project. Another shot with Starship docking in the central hub, which is motionless compared to the rest of the ship, allowing for docking. This type of segmented rotating capability does not exist yet, and the amount of force required for this structure to spin up the 150 plus ton Starship would be significant, and it would most likely cause the rest of the station to slow its rotation significantly. Next we have the cross-section of the elevator system and the 4-level modules. As we went through before, that elevator scheme is extremely poorly thought out. We have the still frame from the restaurant with people enjoying the sunrise over Earth. 2 problems with that. Those windows will be on the dark side of the station, never exposed to the sun, and they certainly won't be facing Earth in that profile. And check out the shape of the windows. They don't match anything in any of the outside views. Now they're going to recycle the rest of the ridiculous CGI images from over the other presentations they've done. The gym, which is pointless in space, and the windows again are inconsistent with any other outside shot. Also, check out the dimensions of this space. Where is that going to fit in any of the modules? Then we get to see the difference between a standard room and the luxury suite, again with grossly exaggerated dimensions and inconsistent window designs. The view would likely be nothing but a blackened rotating starfield. There will be no sunlight coming in through those windows. That's according to the condo designer. And this shot of the proposed propellant depot is laughable, because in the sun-sync orbit, those starships that are supposedly delivering propellant to the station would be maxed out at 40 tons of payload, and have to spend 4,600 tons of propellant to get it there. They can't make propellant in space, and they can't even maintain the propellant volume on board due to boil-off. The longer those tanks sit there, the less product they're going to contain. One of the biggest pieces of nonsense associated with this presentation is the company's claim they believe NASA would be interested in partnering on and using their platforms. Apparently, John and company are completely oblivious to the fact that NASA is already developing technology in-house in their program called OSAP, the On-Orbit Servicing, Assembly, and Manufacturing Program. NASA's promotional video on the topic gives you a pretty good idea what their goals and development look like, and there's no question that whatever Orbital Assembly thinks they're bringing to the table, they're sorely mistaken. Investors need to realize the promises OAC are making with regards to their technology are mainly nonsense, and that the amount of money they have paid in so far will likely be just the beginning of an unending money pit that has no ability to make good on their prospectus goals. That's going to wrap up Part 2. Part 3 is going to dissect their prospectus and tell everyone what they actually bought when they reserved their 25-cent shares. And that is going to open some eyes.